Hey guys, in this lecture, I am going to explain the need for WebFlux. Before we get into that, you will be seeing that I have copied a few slides from my previous course, so don't worry about that. Just please watch this. I am using this to explain the concepts. Okay? Usually, we will have an app or web server like this. This server will be maintaining a pool of threads, say 400 threads. As and when a new request comes in, this server will assign a thread for the request and to get the task done. The problem with this approach is that one single thread is allocated for the request. As part of the request, let's say we need to call some external system or run a long-running database query, etc. The thread will be kept in waiting state. It does not do any other work. It simply sends the request and waits for the response to come back so that it can respond back to the user. Also, each thread needs to be assigned up to 1 MB of stack memory. If you have like 1 GB RAM and if you are expecting 400 concurrent requests, then you need 400 threads. So 400 MB of RAM will be used just for these threads alone without including the memory required for doing the actual work. Now this is the era for microservices. They have become very popular over the years, mainly because of cloud computing. They provide the flexibility to scale out or in whenever we need. Even though microservices solve some of the problems with the traditional architectures, they have their own challenges like a lot of network calls. Microservices kind of worsen the problem of thread waiting or blocked state. This is where WebFlux comes into picture to utilize the system resources very efficiently with just a few threads. With WebFlux and the reactive libraries, we do not keep the threads in waiting state. Instead, any I/O requests or network calls are done in a non-blocking way. That is, it will send the request and it will not sit idle for the response to come back. Instead, it will do some other task till the response comes back. So, we can do a lot more work. When the response comes back, it will be notified. Hey, you sent a request few seconds ago, right? So we got the response now. Take this. So something like this. So threads will be notified. Then the thread will be doing the pending operations to be executed. Let me explain this with a simple example to understand this better. There is an external service. Whenever we send a request, this guy will be taking 5 seconds to respond. Even if you send an infinite number of requests to this service, it can handle all the requests, but each request will take 5 seconds. Something like that. Let's assume so. Now, you need to call this service from your application. Let's assume that you developed that application using Spring Web Module, the original web framework with the servlet APIs and containers. Okay? Usually, you will have 200 threads. To keep things simple, let's assume that you have only 3 threads in the thread pool. Now, what will happen when you have 4 concurrent requests, when there are 4 users sending the request to your application? You get 4 requests, but you have only 3 threads in your thread pool. So, you use the 3 threads from your thread pool to send the request to this service. Okay? So the threads are basically blocked. For 5 seconds it will be blocked. The 4th user has to wait because there are no threads to accept the request. So he has to wait for one of the thread to be free to process the request. Okay. So he was waiting for first 5 seconds as no one was there to accept this request. Then let's assume that 5 seconds passed. Okay, so now the threads are available now. Then they can send this request and get the response back, then respond to this user. Now the first 3 users, they will be seeing 5 seconds response time, which is good. Okay, but this guy, he will be seeing 10 seconds response time because even though these threads are not doing any work, they were not ready to accept this request because they were simply waiting for this response to come back. If we develop the same application with the WebFlux, we can make the HTTP calls in a non-blocking way. So it does not wait for 5 seconds till the response comes back. Instead, it will do some other task if anything available. So now it will see the fourth user request. So it will send that as well immediately. Okay. So because of that, it can process a lot more requests than this Spring Web. So as soon as the response comes back, then it will respond immediately. So theoretically, everyone gets the same response time. So not like this. As it can process more number of requests, the WebFlux server throughput is higher than this Spring Web application. Okay, so I am going to demo this by running a simple performance test in the next lecture.